volume, this looks at the space inside a 3D solid. When we're finding volume, the units that we use are always cubed units, so you'll notice they've got power 3 after them. Please note that this is the unit that is to the power 3, it's not the actual number itself, so it's centimeters cubed, meters cubed, for example. So the most common solids to find the volume of are cubes and cuboids. So a cube is a 6-sided solid with each of the faces being square, which means that if this would be length x, then all of the lengths would also be x. The easiest way to consider volume is, personally, I feel, to imagine your finger is placed on one of the vertices. So this is a vertex. Which 3 measurements meet at that point? So here we have x, here we have x, and here we have x. So we are multiplying those 3 measurements that meet at the vertex. So that would be x multiplied by x multiplied by x, which is considered as x to the power 3. So if we have 5, it would be 5 cubed, which means 5 times 5 times 5, which is 125. Now here is where we need to put our units, so we would put centimeters cubed. The next one, a cuboid. So a cuboid is where we have rectangles as faces instead of squares. Some of them may be square, so just watch out for that. On a cuboid, some may have the same length as each other. But the process is the same for volume. We imagine we have the vertex here. Which 3 measurements? It would be this height, this width, and this length. Now, please don't focus on the height, the width, the length, which one's which, because we could spin the solid around and we would still have the same volume, but they would have different measurements, so the height, width, length. So just focus on saying to yourself which 3 measurements meet at one vertex, and you multiply those numbers together. So if I were to focus on this vertex here, this measurement here, it's not labelled, but I can see it's the same as this one here, so that's a 5. This measurement here, again, not labelled, but it would be equivalent to this one, so that's times 2. And our final one is this height here, which would be 6. So it's 5 times 2 times 6, which gives us 60. And again, our units, centimeters cubed. Now, with the multiplication, don't worry about which order you do it. It doesn't matter. You could have written 5 times 6 times 2, 2 times 5 times 6, 2 times 6 times 5. Whichever order you do it, you still get 60. So our volume for this one was 60. Okay, here's some examples. So if I were to focus on this vertex here, we've got 16 multiplied by 29 multiplied by this measurement. Has no label, but we know it's equivalent to this, so it'll be 17. So 16 multiplied by 29 multiplied by 17 gives 7888. And this unit is meters, so this would be meters cubed. If I were to focus on this vertex, it would be 28 multiplied by 31 multiplied by this measurement, which is missing, but we know it's the same as this one, so it's 27. So 28 multiplied by 31 multiplied by 27 gives 23436, and that would be centimeters cubed. This one, now they've got several different measurements here, lots of different numbers. They're not all necessary though. They've labelled this one 6 and this one 6. It's just telling you the same piece of information, that this dimension is 6. They could have labelled this one as 6 and the bottom one down here is 6 as well. However, they haven't. But please don't let it fool you. Just because they've given you some additional numbers doesn't mean that you're then going to multiply them all together. the method remains the same. Oops. Focus on one vertex. So if I focus on this vertex, I can see my measurements that meet there are the 5, the 7, and this one here, which is not labelled, which we know is 6. So 5 times 7 times 6 is 210 centimeters cubed. Okay, our final two examples. So if we're asked to calculate the volume of this solid, you can see it's a little bit more complicated than the one before. The reason being is that it's not just a cuboid, it's actually, hopefully you can see, two cuboids stuck together. Now they've already done the cutting for you. They've already shown you that you could cut it down this line here to give yourself the blue cuboid. Obviously that goes behind there as well, and then we also have the red cuboid in the front. So they've already shown where to cut it. Sometimes you have to make that decision yourself. So let's focus on the blue one. If I were to consider this vertex here, my measurements are 6 multiplied by 7 multiplied by this measurement here, which I know is just 2. So that's 6 times 7 times 2. 6 times 7 is 42, times 2 is 84. And the red, if we focus on this vertex, it would be this measurement here, which is not labelled, but I know is 4. This one, which I know is 6. And this one, which I also know is 6. So 4 times 6 is 24, times 6, oh gosh, 144. And so our total volume is going to be those two numbers added together. So 144 plus 84 gives 228 centimeters cubed. Our final example. This one's a bit more challenging. You had to visualize a wooden block. Well, it's got a picture there for you, but you need to try and think about what's happening here. And it has a square hole. So the very fact that they've talked about hole indicates something is missing. And when things go missing, they are being subtracted. Okay, so what we're going to do here is we're going to imagine we find the volume of the whole cuboid, then the volume of the whole, and subtract the volume of the whole from the big cuboid. So to do the big cuboid, if I focus on this vertex here, I've got this measurement, which I can see is 5, this measurement, which I can see is 8, and this measurement, which I can see is also 5. So that gives us 5 times 5, which is 25, times 8, which is 200. Okay, now looking at the whole. So this vertex here, we know this height here is 2. This would be 2. Now the other measurement, we can see that the other thing that attaches to that is this big long one, and we know that that is 8. So 2 times 2 times 8 is 32. So this is where our final step comes in, and we would do 200 subtract 32. Gives us our volume of 168 centimeters